Greetings, my name is Phan. I am a Doctorate of Business Administration student at California Intercontinental University. This presentation fulfills the requirement for the Unit 5 assignment of GRC 605, Term 1, 2019. In this presentation, I will be utilizing the statistical software PSPP to review a dataset and determine relationships using chi-square testing. For this presentation's agenda, we will be looking at and utilizing a dataset that has been provided to students for GRC 605. This was discussed in a previous video that's linked in the agenda slide. I'll be reviewing the dataset again in the next slide. The main focus of this presentation is to review 3 chi-square tests utilizing different variables and determining what their results signify in terms of being able to reject or not reject the null hypothesis of each test. Then we will conclude this presentation with some key takeaways and a concluding slide to thank you and provide time for questions and answers. We will again be looking at the same set of data provided by California Intercontinental University. The GRC 605 dataset is comprised of a distilled version of an actual SurveyMonkey survey delivered to a population located in the U.S. Midwest, asking questions about their personal finance situation. There are 10 variables total which make up this data: income, debts, savings, stocks. And here's where we begin the variables which require further clarification. So wallet indicates that this is the self-reported amount of cash the individuals carry in their wallet or purse. Number of cars is the number of car payments per month by the participant. Number of C cards is the number of credit cards maintained by the participant. Number of defaults is the number of defaults of all types incurred by the participant. Likert comfort or like comfort is the self-reported comfort level of the participant with the current financial standing. The measure used a Likert scale where 0 equals very uncomfortable to 4, which equals very uncomfortable. The screenshot of the data is an example of how the data variables are organized. This data set will be used in this presentation to calculate chi-square testing in 3 scenarios. The first hypothesis test was to find a correlation between num cars and num defaults. The null hypothesis, therefore, would seek to state that there is no relationship between num cars and num defaults. The alternate hypothesis states there is a relationship between num cars and num defaults. To calculate the degrees of freedom, n or sample size, chi-square, and p-value, we input our data into PSPP. Select the variables numcars and defaults from our dataset and run a descriptive statistics analysis for a crosstab to find chi and phi. This allows us to identify our needed output. In each of these chi-square tests and throughout this course, when discussing the dataset, we always assume that alpha is 0.05. Our data states that our degree of freedom is 9, our n is 150, the chi-square is 9.7, and p equals 0.375. In this case, because p-value is 0.375 and greater than 0.05, this indicates we have weak evidence from the sample that the null hypothesis can be rejected. Therefore, we will say that there is no relationship between num cars and num defaults. We've now moved on to the second hypothesis test in this presentation. Much of the information appears to look the same, but this time we are comparing like comfort and num defaults. To find a correlation between like comfort and num defaults, the null hypothesis therefore would seek to state that there is no relationship between like comfort and num defaults. The alternate hypothesis states there is a relationship between like comfort and num defaults. Our results here are actually identical to the first hypothesis test. Our data states that our degrees of freedom is 9, our n is 150, the chi-square is 9.7, and p equals 0.375. Again, just like the first hypothesis test, because p-value is 0.375 and greater than 0.05, this indicates we have weak evidence from the sample that the null hypothesis can be rejected. Therefore, we will say that there is no relationship between like comfort and num defaults. The third hypothesis test was to find a correlation between num cars and like comfort. The null hypothesis, therefore, would seek to state that there is no relationship between num cars and like comfort. The alternate hypothesis states there is a relationship between num cars and like comfort. In this example, we have the following data results. The degree of freedom is 9, and n is 150. This is the same as the past two tests. However, this time the chi-square is 450, p-value is 0.000, and v is 1.00. This is quite significant. The p-value is 0.000, indicating there is extremely strong evidence to reject the null hypothesis. However, in chi-square testing, in order to reject, we must also present Cramer's v. In this case, v equals 1.00. What does that mean? Well, thanks to the slide provided by Dr. Stephen Hess from California Intercontinental University, we can see from a reference table that when v equals 1.00, that the variables are perfectly symmetric. That means with very little doubt that we can reject the null hypothesis and not reject the alternative hypothesis stating there is a relationship between numCars and light comfort. Here's a look at the reference table for you to see. In the third hypothesis test, v equals 1.00. Therefore, we interpret that as being perfectly symmetric. As you can see in the third column, this occurrence is very rare, and the independent variable perfectly predicts the dependent variable. Here are a few key takeaways from this presentation. PSPP can be used effectively to calculate chi-square. Calculating manually is possible, however, this calculation can be cumbersome depending on the amount of rows and columns that you're doing in terms of variable calculations. The null hypothesis in chi-square testing seeks to state that there is no relationship between variables, that they are independent. The alternate hypothesis seeks to state that there is a relationship and that the variables are not independent. When rejecting a null hypothesis in chi-square testing, you must also provide Cramer's v. Providing the p-value alone is not enough, therefore to prove your evidence and show that it is strong, you must also provide Cramer's v in order to reject a null hypothesis. I'd like to thank you for taking the time to view this presentation. In this presentation, we focused on chi-square testing and the significance of independent variable relationships. I hope you were able to be informed on the additional functionality of PSPP and how it can be used to calculate the chi-square. I will now leave time for any questions regarding this presentation. Thank you.